Okay, from solving equations in section 1, we're going to move on to using some of the similar steps to solving linear inequalities. And with that, we're at the end of this lesson, you're going to be able to solve one variable inequalities and graph them on a number line. And we're also going to write and solve word problems using inequalities. So before we get into that, we need to have some basic knowledge of, or background info that we've covered in Algebra 1. One of those is that solving inequalities is just like you would solve an equation, except that we're not going to have an equal sign in there. 2, we need to remember the 3 flip-flop rules. Now, what are the flip-flop rules? What I'm referring to is with inequalities, if you ever divide by a negative, you have to flip the inequality sign. For example, if it was greater than and you divide by a negative, you will flip it to a less than symbol. If you're going to flip the entire inequality, meaning that if you're going to take the right and the left side and switch places, you have to flip the inequality symbol. And the last one, just like dividing by a negative, if you multiply by a negative, you will also have to flip the inequality sign. When it comes to graphing the solutions on the number line, we need to remember that if you have a greater than, less than symbol, that means that we're going to use open dots to represent the solution. And if it is greater than or equal to or less than or equal to, we're going to use closed dots to represent the solution. So let's solve an inequality here. We have 5w plus 3 is greater than 4w plus 9. We need to get the w all by itself on one side and the numbers all by itself on another side. And first I'm going to use the I test to determine would it be better to subtract 5w from both sides or to subtract 4w from both sides. If at all possible, I'd like to keep that coefficient positive, so the best move here would be to subtract 4w from both sides. Once I subtract that and then simplify, we're going to have w plus 3 is greater than 9. The last step I need to do is to subtract my 3 from both sides, and I'll have an inequality solution that says w is greater than 6, meaning that my answers are all the numbers that are bigger than 6. When it comes to graphing it on the number line, we need to look at that symbol, and it does not have a line underneath of it. It's just strictly greater than. So that means I'm going to use an open dot at the number 6, and I'm also going to shade to the right. And again, the reason why I'm shading to the right is because it's all the numbers that are bigger than 6 are to the right. So we've got our open dot and shade it to the right. So there's what your solution would look like on the number line. A couple more examples. Here, negative 4.2 times x is less than or equal to negative 29.4. The opposite operation of multiplying by negative 4.2 would be to divide by negative 4.2. Now here is where I have to use one of my flip-flop rules. I've divided by a negative, which means I have to flip my inequality sign from less than or equal to a greater than or equal to. And I'll have a solution that says x is greater than or equal to 7. Looking at my symbol, I have a line underneath of it. So this says I have to use a closed dot. The numbers that are bigger than 7 are to the right, so I will shade to the right. So I put my closed dot and I shade to the right. Another example, this one's got some more steps involved, but still I need to use it as an approach of solving it just like an equation. If you think back to our last lesson, it said if you had any grouping symbols, parentheses, brackets, we need to get rid of them. So that means I'm going to use distributive property twice on the left, and I'm going to use distributive property twice on the right. Once I use that distributive property, I will end up with 24v minus 18 less than or equal to 20v plus 6. Again, I'm using the I test here to see would it be better to subtract 24v from the left or to subtract 20v from the right. Trying to keep it positive, I'm going to subtract 20v from both sides and simplify. I'll end up with 4v minus 18 less than or equal to 6. Isolate the v by adding 18 to both sides. And moving to the right side here, we'll end up with 4v less than or equal to 24. And finally, we're going to divide both sides by 4 to get a solution that says v is less than or equal to 6. So looking at my symbol, I have a line, which means a closed dot, just like the last example. But this time, v is less than or equal to 6, meaning the numbers that are smaller in that direction would be to the left. So I'll put a closed dot at 6 and shade everything to the left to represent these solutions. Now here I got two more examples. What I'd like you to do is pause your screen, work out both of them, and try to graph them on your own number line. Okay, let's see how you did here. The first example here was pretty similar to the first example on the last slide. I will get rid of the negative 9.2 by dividing both sides by negative 9.2. I'll apply my flip-flop rule by switching or flipping the less than to a greater than. And I'll have y is greater than negative 2.5. Looks like I'll have an open dot at negative 2.5, and I will shade everything to the right since it is greater than. More steps involved here on the second example. We have a division, which is very similar to like the grouping. We need to get rid of that division sign. So if it's opposite of dividing would be to multiply by 5. So I will multiply both sides by 5. Now the left side will give you negative 15x, but on the right side, those 5's cancel each other out. And I've been using this concept of the I test to see which one would be better to move the x's to keep it positive. Well, here, if I wanted to make it positive, I'd have to add 15x over, which would force me to move the 22 over to the left side. I want to go ahead and just get all the x's to one side anyway, so I'm going to add 4x over to both sides. Yes, my x is still going to be negative, but at least the x is on one side and my number is on the right side. I'll divide both sides by negative 11, and again, I divide it by a negative, which means I will flip my inequality sign, and I will have x is greater than or equal to negative 2. Greater than or equal to means a closed dot, and then greater than is everything to the right, and there is your solution set for that example. So take a look at your work and what we have here on the screen, and hopefully you did well with that. The last thing that we're going to look at is a word problem with inequalities, dealing with a website. So Enrique's company pays Salem to advertise on Salem's website. Salem's website earns $15 per month plus an extra 5 cents every time a visitor clicks on that advertisement. What is the least number of clicks per month that Salem needs in order to earn at least $50 per month? Now there's a lot of per going on here and every time, so we're thinking a lot of multiplication here. But if I look at the last sentence here, it says, what's the least number of clicks per month that he needs? We're just going to look on this on a 1 month basis. So it's the month of September right now, so let's think how much he can make just in September. So there's a few questions I'd like to ask, or you would need to ask yourself throughout these problems. First is, how much is Salem guaranteed to make in just 1 month? If you said 15, you're right. Because it says he's guaranteed to make $15 this month on the website. The next question is, how much can he make, or how else can he make some money? Well, the other way that he can make some money is if somebody clicks on the advertisement, and every time somebody clicks on it, he gets an extra 5 cents. So 5 cents each time a visitor comes to the site. The last question you would ask yourself, how much is Salem trying to make per month? And if you look in the last sentence, it says he's trying to earn at least $50. At least $50. So if he can make more, that would be awesome. So now we need to come up with some type of an expression and an inequality to represent this. Let's come up with an expression that represents just how the possible amount of money that he could make. So we know for a fact, in just 1 month, he will make $15 plus an extra 5 cents every time. So if he's going to make 5 cents every time that he clicks on it, it would be 5 times the amount of clicks. So what we have here is we're going to have $15 plus 5 cents per clicks, per meaning multiplication. So this would be an expression that represents the amount of money he could possibly make depending on the number of clicks. Now we need to use an inequality in here. We need to think, should this be less than, greater than or equal to, less than or equal to, compared to the amount of money that he's trying to make? Here he's trying to make $50 and he doesn't want to go below that. So the expression that I have here needs to be greater than, and it's equal, because he's okay with having $50 to the $50 amount. Now that we have that inequality, we can go in and solve and figure out the bare minimum clicks that he needs to have on this advertisement. So we'll subtract 15 from both sides. We'll end up with 0.05c greater than or equal to 5, which will cause us to divide both sides by 0.05. And we're going to come out to c is greater than or equal to 700. So what we found out is that